Okay, we are recording now. This is the review for test number 3, second 6 weeks, fall of 2014. Your test will be multiple choice. What are you laughing at? I didn't know this. The temperature in here is about 105 degrees Fahrenheit.
Hey.
Yeah, that's a little bit above optimal brain capacity temperature. But that's okay. We're going to stretch each other here. So, the whole test is multiple choice, which means then that you at least have 4 answers to choose from. I think a lot of you would choose to answer this question by just simply putting it in the calculator. Others would rather work it out by hand. I think if you're going to put it in the calculator, you might find that it's at least advantageous to do a couple of things by hand. First thing, if I have the equation right here, if I'm going to do it by hand, I want to set it equal to 0, don't I? So I'm going to have this. I'm going to have 7 times the tangent of x minus 6 minus 13 tangent of x is equal to 0. I have like terms, 7 tangent of x and negative 13 tangent of x. I combine those together, I get negative 6 tangent of x minus 6 is equal to 0. Do the algebra here, I have the tangent of x is equal to negative 1. If you don't believe me, add 6 to both sides and divide by negative 6. 6 divided by negative 6 is negative 1. Now I'm going to do this too. I'm going to put the tangent of x plus 1 is equal to 0. And the reason I'm doing that is because if you're going to put it in the calculator, you would want to put this second expression in rather than the first one. Right now, doing it by hand just simply means that we want to find the angle x whose tangent is negative 1. Well, the only places you're going to have a tangent of 1 on the unit circle is at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Those are the only places on the unit circle where you're going to have a tangent of 1. Now, we don't want a tangent of 1. We want a tangent of negative 1, don't we? And so, that being the case then, we need to figure out where you're going to have a negative tangent. Well, that's always going to come from angles in quadrant 2 and angles in quadrant 4. Well, how do I know that? Well, remember, tangent is the y divided by the x. And the only place where you're going to have an x and a y divide out to be 1 are at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Since we need a negative 1, then we need at least one of those, either the x or the y, to be negative. That only happens in the 3rd and the 4th quadrant. So just by the algebra alone, y'all can tell that B is going to be the answer choice. But if you want to do it by calculator, again, you could put the whole thing in. Since I've already worked it out by hand, I'm going to use this tangent of x plus 1. So I go to the calculator. Notice I have a calculator now. All right, what I want to do? I want to do whites. Okay, notice I already have tangent of x plus 1 because I want to set it equal to 0. And then what I want to do, and I need to be in what mode? Radian, because we're talking about graphing. I am in radian. Okay, so I'm going to go to second graph, and there's my table, and you can see where I have some numbers punched in. What I'm going to do is go back up, and I'm going to delete those. Now, from where you're sitting, you may not be able to see very well, okay? But trust me, what I'm doing is this. I went into my ask function, and I want to know. I have answer choices, right? Let's say that we're looking at A as the answer choice. So we have pi over 4 and 7 pi over 4. Well, if that's the case, then I should be able to do pi divided by 4 and hit enter, and the result should be 0. And no, I can't write on here. Okay? Well, I'm going to fix it so I can. The result should be 0, and it's not. It's 2. So what does that tell you about pi over 4? Doesn't work, does it? Okay, what about 7 pi over 4? 7 pi divided by 4. I type that in, and I got a 0 up here in the table. So I know 7 pi over 4 works, don't I? Well, from process of elimination, then, I know that A won't work. I also know then that C can't work because it contains a pi over 4. Then the only other one I want to check is D, and the difference between B and D is D contains a 5 pi over 4. So I'll type in 5 pi divided by 4. That also doesn't work. So I can tell by elimination that B works. Now, are there simpler methods for here? Again, that's really up to each individual. Which way is better? Again, you choose which way is better, whether you do it by hand or by calculator, as long as you know how to check to find out if your answers are correct. So B is the correct answer here. Okay, so this problem right here, number 2, again, we can do this with a calculator or we can do it by hand. If you did it by hand, then what you would have is 5 times the cotangent of 2x is equal to 5 squared root of 3. So you have the cotangent of 2x is equal to 5 square root of 3 over 5. These go away. So you have the cotangent of 2x is equal to the square root of 3. Now the problem with this thing by hand is that you're not solving for x, or you're solving for x, but you have a 2 connected with the x. So that goes back to the class session we had a few class sessions ago. We said this. Notice our interval from 0 to 2 pi. So we want to find all the answers that work on the interval from 0 to 2 pi.
Can you do reverse?
I can't. But right now I want to find out how many answers I need. So what I do is I just sort of ignore this 2, and I say the cotangent of x is the square root of 3. Right? Now cotangent, if you'll remember, is the x component over the y. And the only place that's going to happen on the unit circle is when you have a square root of 3 over 2 for an x and a 1/2 for a y. So on the unit circle, we want to find all the points that are square root of 3 over 2 and 1/2 on the unit circle. That's what we want to do. Now that's sort of how we're going to find those. We need to find out the number of answers, and that comes from the fact that we are doubling the angle. And if we were on one rotation, we would only have 2 answers. Now I know that we're going to have 2 answers because of this. I know that I'm looking for a coordinate in which when I divide x and y, x on top, y on bottom, I get a positive square root of 3. That's going to happen when I have square root of 3 over 2, comma 1/2, and also when I have negative square root of 3 over 2, comma negative 1/2. So there are only 2 solutions to cotangent of x is equal to square root of 3 on the interval from 0 to 2 pi. But remember, we're doubling our angle, so we're doubling our interval. So instead of just 2 answers, we're going to have 4 answers. Right? Well, now, just knowing that alone will tell us that we're having D is our answer, because that's the only place where we're going to have 4 answers. But we can always check this, which goes back to the other way people like to do this. They like to put it into their calculator. So if I'm going to put it in the calculator, I want to go back to y equals here. I want to clear that out right there. And if I want to type in my equation, I'm going to have to type it in like this. 5 parentheses, and cotangent is 1 divided by tangent. Then I want to put in a 2x. And what I want to do is do double parentheses, because that is my entire cotangent. And then I'm going to subtract 5 times the square root of 3. We're still recording, y'all. 5, and then I need the square root 3, like that. So I have my equation in, and what I want to do then is, if I want to check answers, I'm simply going to go, I need to make sure I'm in the right mode. I need to be in radian mode, and I am. So I'm going to go to my answer choice thing there, and I'm going to just go ahead and delete all my choices out. All right, and so here's what I want to do then. All right, we've already decided that D is the correct answer here, but let's just check. Let's say we were just using our calculator. Let's say we thought A was the correct answer. So if we did, we have pi over 12 and 7 pi over 12. So pi over 12 and 7 pi . Now notice in both cases, if you look at your table on the right, you have 0, and then you have that negative 2e to the negative 12. You just have to understand that negative 2e to the negative 12 is a number that's essentially 0. So we know that pi over 12 and 7 pi over 12 are the correct answers. We know that, don't we? But if we go and we circle A as the correct answer, that's not the best one, because answer choice B contains the same 2 as these plus 13 pi over 12. So we want to go and check 13 pi over 12. 13 pi divided by 12. Right, again, 2e to the negative 12. That number is extremely close to 0, so we'll count that as being good. So now that means then that B is a better choice than A. Right, so we can do C. If you look at C, C contains this pi over 3. Put it in your calculator and you'll find out that will not give you 0. So C is not going to work. That rules out everything but D, and if you feel confident, D contains everything that A and B contain plus 19 pi over 12. And if you put that in the calculator, 19 pi over 12, again, you get 2e to the negative 12, which is 0. So that's how we can use our calculator to find this answer also. All right, number 3, it tells you to use information to solve the triangle. So if you guys have been around me long enough, you're going to know that the first thing you need to do is draw a triangle and label the angles A, B, and C. It doesn't matter where you put them as long as you put one letter per angle. It doesn't matter if it's drawn to scale as long as it's oriented right. Now that we've marked the angles, we know side A has to be opposite, and it's 9. And we know side B has to be opposite, and it's 10. Notice what it says. You want to find lowercase c. So when it's all said and done, we want to find lowercase c. Well, we have 4 answers to choose from. One of the answers gives us 2 c's. Another one gives us 2 c's. One of them only gives us 1, and then one says no solution. Well, if you will recall from way back, this type of triangle that we're given is a side-side angle triangle. And when you have that, you have what they call the ambiguous case, which means that there's the possibility of 2 solutions. It's possible. And here's how we did it. No matter how you do it, you have to solve for angle B first. You have to. There's no other choice here. So, here's what we're going to do. I'm going to solve for angle B. So here's what I know. I know the sine of angle B divided by side B is equal to sine of angle A, and we know angle A, oh, I didn't mark it, my mistake. Angle A is 39 degrees. Divided by side A. Okay? If you go through the algebra, here's what you're going to find. You're going to find that the sine of B, all right, and I'm going to just do it on my calculator off to the side. I'm not going to pull it up on the screen. I'm just going to do 10 times the sine. I need to make sure I'm in degree mode. I'm going to do 10 times the sine of 39. And I'm going to divide that by 9. And I get 0.69924, etc., etc. Okay? And then what I'm going to do is take the arc sine of that. And I get 44.4. So I know that angle B is 44.4, which means that I can go ahead and do the math to solve for side C. I can go ahead and do that. In fact, I'm going to elect to go ahead and find side C based on this triangle right here. Well, to do that, I need to find angle C. Well, angle C is just simply found by taking now 180 and subtracting the sum of 39 plus 44.4, right? And I get 96.6. So I know angle C is 96.6. So now I can find side C to be this. I know that side C for this triangle can be found like this. C divided by the sine of 99.6 is equal to the side A over the sine of 39. Now I could have used the B and the B part, but I just stick with that right there. So that tells me through algebra, and I've already done this, you do the math, 9 times sine of 99.6, divide that by, thank you, I can't seem to write my stuff correct today, 96.6. Do the math, you get 14.21. Now the problem with this is if you think that answer choice C is automatically the answer, you could be wrong. Because if you'll remember, going back to this, you had a side-side angle. So it is possible that 2 triangles exist. It is possible. How do we test for that? Well, we test like this. And let's see, this is where, I'm going to scroll this down here. If I drew another triangle like this, right, if I did A was 39, right, and I knew then that I had 9 and 10, right, I could go through the whole thing again. I could say then that the sine of B over 10 is equal to the sine of 39 over 9, right? And here's what I would find. I would find that the sine of B is equal to what it was before, 0.69924. But the problem now is that B could also be the supplement of what we just found, 180 minus 44.4. So instead of this one being 44.4, it could be 180 minus 44.4. So if I go to my calculator and I do 180 minus 44.4, I get 135.6. Now here's the situation. Well, hold on a second. I'm here. Hold on. I'm hearing some comments, but let's just finish this out. So, how would we know that this triangle exists right here? Triangle 2. How would we know? Well, if I take 39 and I add 135.6, is it less than 180 degrees? That's the question. The answer is yes, it is. So, because if I take 39 plus 135.6, I get 174.6. which is less than 180, which tells me then that this angle right here, let me do that real, 180 minus 174.6, it's 5.4 degrees. Now again, my triangle is never drawn to scale. I'm just showing the orientation. So what does that tell you about the other side C? No, there is a solution. This triangle exists. So there is another side C. And I can go through all the math, but y'all, hold on a second. We've already found, we know there are two solutions, right? And we've already found one of the solutions to be 14.21. Now look at their answer choices up here. You only have A or B to choose from. Which one's got to be correct? It's got to be A. A has got to be correct. Now where you may have trouble is what if both of these answer choices contain 14.21? Then you would have to continue to work it through. Question? I got 5.4. The question is, how did I get 5.4? First thing, I have to consider the fact that this angle B, the new angle B right here, could be the supplement of this angle B up here. I have to consider that fact. If that's true, then this angle B could be 135.6, which then if I use angle addition and work it through, 180 minus 135.6 plus 39 is 5.4. Again, my triangle that I drew doesn't do it justice, but that's how that works. So the correct answer here, just by elimination, would be A. A is the correct answer here. All right, we're back again. This one says use the given measures to find the area of triangle ABC. So we're finding area now. So again, the way I do it is I'll draw a triangle. Again, they're not going to be scaled correctly, but they're oriented correctly. I know A is 23 degrees. I know side A is 4.4. I know side B is 4.4. I want to find the area. Well, if you'll remember, the area of any triangle can always be found by 1/2 times the base times the height. We found an alternative formula that's based on this, which is 1/2 times 2 legs that make an angle times the sine of the included angle. Now I know 2 legs up there. I know A and B. The angle between A and B is angle C. So, one way I could do this, if I know what angle C is, then I've got everything that I need. Well, if you look up there, you go, well, how are you going to find angle C? Well, you could use the law of sines and all that stuff, or the law of cosines, but let's get a little bit more basic. Did you notice that you have two sides that are identical? That means that the base angles are identical. So if angle A is 23, angle B is 23 also. Right? It's very easy. And so then that case being the case, I know that angle C, I'm going to do this with the calculator on the screen. I know that angle C is just simply going to be, let's go back to our screen here. I know angle C is just simply going to be 180 minus 23 plus 23. So I know angle C is 134 degrees, don't I? So, pull that away. Now it's just simply going through the math. 1/2 times 4.4 times 4.4 times the sine of 134. Question? Because that is, why do I have 4.4 twice? As long as I know two sides and the angle between them. That is a derivative of this formula right here. And what you find out is the height, I can drop a triangle right here, and the height is always going to be the sine of the angle times one of the side lengths. Okay? Yes? They're all on the test. Every single one of them.
I'm talking about like
every last one of them. What mode should I be in, Ian? Good job. All right, what's your question, Ian?
On the test, is this going to be the problem? It's not going to be like three different sides. Two sides are the same.
Ian's question, oh, by the way, the answer is 6.96. Ian's question, could you have a problem on the test that instead of giving you nice sides that are even and you can figure that out, could they be different lengths and you have to use the law of sines or cosines to find the other stuff? Yes, that's possible. That is possible. Honestly, I don't remember what's on the test.
Well, okay, all right, what do you do?
Can you show us the way?
Hold on. So the answer choice here is A. Can I show you the way? Not without deviating from what we need to do. So if we have time later, I will do that. Okay. This one should be pretty straightforward. Right? We have 5u plus 2v. So we have 5, and we know vector u is negative 5i plus 5j. And then we're going to add 2v to it, so that's 2. And v is negative 9i minus 4j. So if we just simply distribute, now we could turn these vectors I and j into components, but we don't need to, because all we need to do is distribute. 5 times negative 5 is negative 25i. 5 times 5 is 25. So when I do 5 times vector u, I get negative 25i plus 5j. And when I do 2 across, I get negative 18i minus 8j. And I'm adding, correct? So add components. What's negative 25 plus negative 18? Well, negative 25 plus negative 20 is negative 45. Subtract 2, you get negative 43. Or you could just use your calculator. It works the same way. And what's 25 minus 8? 7. Okay? So my answer is 14i, negative 43i minus 17j. And there's only one answer choice that works there. So it's that one there. That is. Thank you. Okay? All right, now again, could you have turned those into components and worked it that way? Absolutely, you could have. Is it best? That's your choice. You're the one that decides, which way is best for you. But that was pretty straightforward. A has to be the answer there. All right, this one says find the direction angle of the vector. So one thing you can do, and you do not have to do it this way, but just to illustrate, here are the x and the y axis of a graph. The x and the y axis. My vector is negative 9i plus 7j, which in component form is the same thing as negative 9, 7. And if I make it a vector in standard form, then it's going to be somewhere over here in quadrant 2, which means by definition, my direction angle has to start on the positive x-axis and go in a positive direction and land where the vector lands. That's my direction angle. We've already learned this earlier. The shortcut to the direction angle is this. You just simply find the arctan of the components. My components are 7, negative 9. It's always the y component divided by the x component. Now, if I go into my calculator, and if I work this out, I'm going to have the arctan of 7 over negative 9. So what I'm going to have is the arctan of 7 divided by negative 9. And again, I want to make sure I'm in degree mode, and I am. Now, that angle is a negative angle. It's negative 37.9. We'll call it negative 37.9 for brevity's sake. So theta equal negative 37.9. If you look at your answer choices, you don't see that up there. But you do see 37.9, so some of you may say, well, I just did a mistake, it's got to be D. You would be wrong in doing that, because that negative 37.9 is actually this angle right here, right? We want to find this angle right here, so therefore they're supplementary. So what do we do to this negative 37.9? Our actual direction angle is going to be the supplement. Okay, you take 180 minus 37.9, you guys can see what that's going to be, but 180 minus 37.9, and you get 142.1. Now again, we rounded, but A has got to be the correct answer choice. 142.1. Yes, you could. That was the other way. If you look at that, there's only one angle in there that's in the second quadrant. So you could rule out B, C, and D automatically just by looking at where the vector is located. Will they always be that way? No, not necessarily. It could have been that all your answer choices were in the second quadrant. Then you'd have to figure out the work there. Yes, question. Quadrant 2 and 3, you add 180. Quadrant 4, you add 360. Quadrant 1, you leave it alone. Now this problem here, we did this in another video, so you'll have to refer to it, but the correct answer is A, and that comes from having to draw a second triangle. And again, if you go to page 434 in the textbook, example 9, you have a problem a lot like that. Now this one here says identify the vector with the same magnitude as V. This is vector V right here. And to find its magnitude, what I need to do is find the components. So my components for vector V, and it's always the terminal minus the initial, so it's 1 minus negative 3, comma, 8 minus 3. Those are going to be my components. So if you do the math here, vector V has components 1 minus negative 3 is 4, 8 minus 3 is 5. So you have the components 4, 5. So the magnitude is pretty straightforward. It's just simply the square root of 4 squared plus 5 squared, as long as you know components there. So that's the square root of 16 plus 25. Let me check my math right quick before I go any farther. 1 minus negative 3 is 4. That'll be 1 minus negative 3. 8 minus 3 is 5. 4 squared is 16. 5 squared is 25. 25 and 16 is going to be what? 41? Okay? Now I can go turn that into a decimal and all that stuff, but I'm not going to need to, because what I want to do is I want to figure out whether vector W, vector U, vector T, or vector R, circle those wrong, have the same magnitude. That's all I need to do. So one way to do this is to actually find the components for this. Now if you look at the graph, components are not as hard as you think, as long as you have the graph. Because the components are always the horizontal and the vertical from the initial to the terminal. So if I want to find U right here, what I do is I look, what is this vertical component and what is this horizontal component? So vector U, I know this. If I start at right here and I go down to here, I'll go 1, 2, 3, 4, 5. So I know that component's 5. And when I go this way, I go 1, 2, 3, 4, 5, 6. So I know vector U has components 6, 5. Right? I know, or it could be -6, -5, but magnitude-wise, we're the same. Now you can always go back and look at the actual points. This point right here is -1, 3. That's the terminal point for U. This point right here is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that's -7, 7. Okay, that's the initial point for U. So if I do it the other way around, I have -1 minus -7. Right, so that's -1 plus 7, which is 6. And I have 3, did I do my coordinates right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I did that right. -1, 2, not 3. That's -1, 2. My mistake. All right, so what's 2 minus 7? That's -5. Now I realize down here I don't have positive, but I'm just looking at magnitude. That's all I'm doing. So anyway, if I square 6 and I square 5 and work it out, I'm not going to get 41, am I? So we know that U doesn't work, don't we? We know that U doesn't work, do we? We can go through the same method by finding points and stuff like that. But if we look at vector, I don't know, let's pick W. W is the next one, or it's the first one in line. If I want to do W, then my horizontal is 1, 2, 3, 4. And my vertical is 1, 2, 3, 4, 5. Okay, now, we have that for vector V, don't we? Right? So, vector W is going to have to be our answer. It's going to have to be A. But let's just check one more time. Let's check, say, T. Right? If we want to do T, as far as our horizontal component is concerned, we have none. How come? Because there is no right or left movement. It's straight up and down. And then the other way is 1, 2, 3, 4, 5, 6, 7, 8. In absolute value terms, T won't work. And you can go back and do the same thing for R. R is a horizontal vector, so it's going to have 0 in there. So no matter how you cut it, A has to be the right answer. It has to be answer A.
Divided by 3.
All right, this says find the area of the oblique triangle with given measures. It's an equilateral triangle with perimeter of 21. So if you wanted to draw it out, right, A, B, C, the perimeter is 21. So what does that mean then that each one of these are? It's 21 divided by 3, so each one's 7, right? Now in an equilateral triangle, all the angles are automatically 60 degrees, aren't they? Right, so that's all good to know. And from that, you could, if you wanted to, do the 1/2 times the base times the height area thing. You drop it perpendicular, figure it out. But when you have all 3 sides, you can use Mr. Heron's formula. And Mr. Heron's formula says this. Let me make, well, it's not going to work for me. So I'm going to write it over here. Actually, I'm going to erase this. Okay? Heron's formula says this. First thing you got to do is find S. Well, S is the perimeter divided by 2. So S is 21 divided by 2. And 21 divided by 2 is 10.5. Then all you got to do is take the square root of S times S minus A times S minus B, which I know these are all the same, times S minus C. Take the square root of that whole thing. That's all you got to do. So, do you notice you have three of the same things right here? So, calculator-wise, I can just simply do 10.5 minus 7, and I'm going to cube that, because I'm multiplying times 3, right? Then I'm going to multiply that times 10.5. All right, now my area is not 450.1875. My area is the square root of that. So my area is 21.21 or 21.22 on there. Okay? So that means then,
Why couldn't you do that 1/2?
I had a question, why couldn't I just do that 1/2 thing? Well, the answer to that is that to find that 1/2, I need to find a height.